mobile malware identification and remediation, DDoS defense, and threat intelligence automation. Russ has a bachelor's degree from some place called the UW-Madison. I don't know if you guys are familiar with it. I've heard good things, though. In computer engineering. An MBA from Marquette University. We won't hold that against you. He's working towards the SANS Masters in Information Security Engineering program and currently holds the GSEC, GCIA, and GCIH certifications. In breaking news, he had a SANS Gold research paper accepted, which will be published in the next few weeks. Let's give a warm welcome to Russell Fromm.
Test here? Yeah, there we go. Get a little closer. All right. Thank you for coming for the last technical session of the day. So I'm going to be talking to you today about a lot about microsegmentation and also kind of what I see the industry kind of evolving towards with nano-segmentation and kind of educate, hopefully inform, and entertain you as we kind of go through this journey. Before I get too far into it, I do have a standard disclaimer. I am going to talk about some ways to get around some of these controls and how to counteract those as a defense. I am pretty much a blue teamer in my day-to-day role, so I work in the defensive side, and that's primarily what this is on. Also, anything I present, any opinions I have don't represent my employer or any past employers in any way. Okay, so before I get into this, I want to talk a little bit about some cloud server results coming in and what people are doing, because what I'm hearing on a lot of the security podcasts seems to be a little different than, especially what I saw in these results here. Especially here that it seems like there's a lot more investment going into the private cloud, and that's mostly what I'm going to talk about today, as private cloud, hybrid cloud, and those types of solutions that are very popular with using microsegmentation. What really surprised me, especially with these results, even though it is from 2017, is that the traditional data center is not dead. It's actually getting a tremendous amount of investment. As well as hybrid cloud is coming in, and then finally coming in with public actually was a lot less than I expected. For the vendors chosen, not a lot of surprises here. It's basically Cisco ACI. I'm going to choose, or VMware NSX. You've got some other players such as Ericsson, Nokia, which isn't listed there. Juniper comes in, a lot of smaller players, Big Switch, new upstart, startup coming in with a major play in white box. However, the surprising thing here was the open source. And I don't know why they didn't choose to name it. Everybody knows it's OpenStack, but I was actually really shocked with the tremendous amount of adoption that's there. You see a lot of that in the telecom industry especially. OpenStack's gotten tremendous adoption. And in my opinion, lately it has cooled down a little bit as the complexity has really hit a lot of the development teams and the difficulty in choosing that route. Now, I'm going to talk a little bit about kind of the soft side of this. Even though this is a technical track, there were a lot of issues deploying microsegmentation that were a little more on the softer side. The technology is something I'm going to get into more later on in the presentation, but coming out, I actually think was the easier part. Having the right set of engineers to come in and run that type of infrastructure is very important. In my opinion, the skill set that's needed is a little more advanced than your typical network security engineer. You can't just take a firewall engineer and put them on this. Can they perform? Yes, but they need to know a lot more about the infrastructure and have more communication with your development teams. They need to know the type of flows that is expected to go through basically all these firewalls you're setting up. So that creates a different type of engineer, somebody who really wants to get in tune and really understand your traffic on a very deep level. You don't typically have that in a traditional enterprise. And that can be a little more difficult and require a little different personality, somebody who digs in, who gets along with developers. The second thing is the workloads. So most of my experience is where what I call legacy apps, which is basically Windows servers coming in on maybe some type of .NET stack, and they want to go cloud right away. Here's some other presenters today talk about it. They kind of call it kind of a lift, kind of like just a forklift into getting cloud aware or having a cloud solution. That's something that I have experience with, and I agree it's not the ideal state you want to be in, but if for one reason or another you're not able to go straight to containers, straight to a software-centric architecture, you need to assume that you have some amount of availability in your infrastructure, no matter what it is. I believe that some of these solutions are really good at providing kind of that fake software, kind of faked up hardware that's virtualized that makes it look like everything is nice and reliable. You don't need to have you don't need to have always on and always available hardware anymore. The software can kind of fake that a little bit, and your application can still run in its legacy architecture that it had. However, one thing to keep in mind, though, it's not an easy button. Even though if you're going into a virtualized infrastructure, different VMs handle themselves differently, and you want to be careful to make sure that you don't just treat them all the same. You can't back them up the same way. One example would be, for instance, a load balancer. You may not want to treat a load balancer VM like your other regular VMs. It's special, it's infrastructure, so it requires a little bit more tact when you deal with it. I put a link on the bottom on there for Gartner. So these are some recommendations I pulled from them that I really agreed with. But if you're looking at evaluating going down this route, I highly recommend looking at some of the recommendations. They have a lot more there. These are just the main ones that I picked out that thought, from my experience, that were particularly relevant. So a big part of this is talking about zero trust. Zero trust isn't a new framework or a new idea, but I believe that microsegmentation really helps push this forward. And in a nutshell, what it talks about is all the code that's executing, all the traffic on your network should have some type of verification before it's allowed to run, before it's allowed to transmit data. You should have some checks in place before it's allowed to communicate or run that say, okay, I trust this in some implicit way. So right now, where I think the industries went with microsegmentation, and I'll talk a little bit more on how it's evolving, there's more checks being put in place. You don't just assume because a server is communicating on a new port, it needs to communicate on that new port. You need to verify that. Is that expected? And I guess a heads up, a lot of what I'm going to talk about today, I'm going to be referencing VMware quite a bit and NSX. That's where I have a lot of background in deploying microsegmentation, but I'm not sponsored by them in any way. It's just the area where I have the most experience. However, a lot of the terminology that I'm going to talk about is interchangeable, are very similar to offerings across any vendor. So taking a step back a little bit and talking about what is microsegmentation, how does it work? So going back to kind of traditional firewall defense, where you basically have your zones. Typically in most enterprise, you're going to have your border firewall that'll let your traffic into your DMZ, and then from your DMZ, you're going to have another firewall that lets you into your core or into different divisions of your company that are then further set out. So you usually have big, powerful firewalls doing rough segmentation of the zones of your traffic, but it's on a very kind of rough and coarse manner. And you end up putting a lot of holes in those rules and always maintaining them, and it tends to be hard to go back and say, all right, we need to review these rules and clean these up. So microsegmentation, and just that, a lot of vendors have slightly different definitions of this, as well as some service providers. My definition, I like to think, is pretty simple. It's basically a firewall on every single software instance that's running. It can have an operating system, it doesn't have to, but whatever you call as a unit. In this case, I'm referring a lot to forklifting in legacy architecture. So I refer to them as VMs, but you could say each container is another way to do it. I believe in getting very fine-grained, getting down to each individual component of whatever is running. And that's what I call microsegmentation. So run onto every system, every unit, every container, every VM, every operating system. Get as fine-grained as you can get. Now, as you're probably thinking, well, oh great, that's a fun thing to implement, because now I've got to manage all these rules. And now, before I used to have, maybe 6 firewalls. Well, now I got thousands. How do I manage all that? How do I orchestrate all that? And that's an area where I think the industry is continually getting better. VMware came out with something called the Application Rule Manager that allows you to kind of assume you're in a clean room environment, generate some rules for you, and put those into production or into development where you're testing it, and go forward with that. And there's also some managers of managers out there that have till now mostly been used for traditional hardware-based firewalls. Now we're going into software-based firewalls. So the idea is when you fully implement it, you now have firewalls everywhere. They're on every VM, they're on every container, and you're in charge of orchestrating all that, keeping up with that, and that is not an easy task. But I'll talk about that a little bit more as we get through here. So basically, before microsegmentation, anything's allowed to talk to anything as long as it doesn't hit one of the big firewalls that you have, one of your core zones that you have already set up. Afterwards, you only set up what is necessary, what is documented as necessary, what you know is necessary, what you've whitelisted as necessary. And this comes back to the idea of zero trust. You'd only let through the communication that is needed and nothing more. Right out the gate, especially, I mentioned earlier that I worked with Windows machines. They're very, very chatty. You're gonna be blocking a lot of traffic right out of the gate because they love to talk. And that is normal. And that type of kind of understanding usually requires a little more finesse from the engineers you have working on this to kind of understand that and set the right thresholds and baselines. So what are some quick wins when you put it in? One major quick win is process compliance, meaning if you have developers changing code, changing communication flows without documenting it or communicating it, it's not going to work, just plain and simple. If the communication changes, even if it's on the night of implementation, after you've spent 6 weeks looking at the traffic, going through all the reports, looking at all the flows, and now all of a sudden it changes the night of, well, that's how it works. If you need to be made aware of what the flows should be for your applications so you know what to allow. This usually gets a lot of people nervous because, this sounds like we're going to have an outage. So this requires quite a bit of, frankly, homework done on your application flows for where you're planning to implement this, what is normal, what is not normal, and making sure that you have the right rules in place. As far as automation, so a lot of the vendors put in built-in tools that help you get started to manage these, usually with security groups, with security tags, other ways to kind of manage the complexity of all these firewalls. That's something I really recommend, is taking advantage of those. And right off the bat, before you initiate a project like this, look at your application stack, look at all the different components of it, what talks to what, try to enforce things like naming standards. It makes this a lot simpler. All the database servers have this in the name, or this unique set. So my background is working in multi-tenant architecture as a hosting provider, meaning we have a whole bunch of customers all using the same blades, sharing resources, but they can't talk to each other, and they only need to talk to what they're authorized to inside their infrastructure or from us for authentication, for example. So this is usually right off the bat, you're going to get forced to do more automation. Now, I do like bringing in some advanced tools that help with this. I like to call them, managers of managers. Tools like Firemon that can kind of help manage this complexity for you and the different versions that come up. Because one thing, you do your initial deployment on this, but after that initial deployment, guess what? The code still changes. Dev doesn't start, or maybe they do now want to say, all right, dev caught up, now we want to switch to more of a containerized strategy. Well, now you have multiple revisions of your rules depending on each customer or depending on your infrastructure where you're at, and those keep on changing and it's ongoing. You really need to embrace change. Whatever speed your developers are going at, you need to go at the same speed and keep up with them. The last part in there is granular network forensics. Now, you would think that that's only good for the network security team, because now we can go in and it's very, very easy to figure out where traffic is blocked, why traffic is blocked, and when spikes happen. But I would argue there's another big win here, and that's using the right tools here. You can share this with your other teams within your organization and share them publicly and say, before they open a ticket, before they pick up the phone, that something isn't working or you think something is blocked, and you always think it's always the security team on trial trying to prove it's not us, it's not the IPS, it's not the firewall. This will help them do some of that initial research before they just pick up the phone or open up a ticket and say, you must be blocking it, can you go look? Well, empower them to look themselves to save you some time and save your whole team's time trying to look these things up and respond to every single complaint. It makes it a lot easier and a lot simpler Up here is a screenshot from vRealize Network Insight, or VRNI for short. It has a nice little animation, kind of like the old Cisco packet tracer that allows you to see where the packets are going and see where it stops. That helps narrow down where to look, where the problem may be. So I just had an example of here. So getting a little more advanced once you've implemented this. So let's say you figured out what your communication rules should be. You're doing a rollout on either on your first customer or either in dev to kind of test it out. Another thing to think about is catching what I call shouldn't happen. So maybe people shouldn't directly log in as root. Maybe you're not expecting things like telnet traffic, FTP traffic, TFTP traffic on some servers, but not on others. Put those rules in. This gets into I hate to use the term thread hunting, but think about what traffic is normal, what traffic isn't normal, put some monitoring in place. In addition, baselining. You usually get an idea fairly quickly of what traffic is normal once you do your first, second, third deployment, and what are false positives. Especially, as I mentioned, on Windows machines, they're very, very chatty. So here's an example I had of what this might look at. So you set up an alert fires up, it hits a dashboard or it hits the SIM, the SOC gets alerted, they get some context around this alarm. Hopefully they do some at least initial investigation into what it is, what caused it. So in this example, they take a look at what's in the syslog server. All right, we see a little spike here, it happened. We got a source, we got a destination. I think we can figure out who did this. So, this is a conversation you may have with an admin, with the SOC reaching out, or a security engineer reaching out who investigated this, saying, all right, I'm going to reach out directly on this ticket, contact them, let them know what happened, and follow our established procedures. So in this case, I have basically a password reset for breaking protocol. Here's another common example. So I mentioned earlier how you kind of catch compliance pretty quickly when you go ahead and implement this. So in this case, what we have is another admin who's responsible for a group of servers. SOC also got alerted. We also have communication coming in that's being blocked. And in this case, the admin knows all about it. He's like, yeah, we combined some servers together. We wanted to save some money on licensing. So that's a common thing, but that wasn't communicated. That wasn't documented. So by default, it gets blocked. Hopefully you don't have an outage or you catch this in dev so that this doesn't impact anyone. But these type of things kind of happen, and this kind of pushes forward kind of a bigger issue in your organization. If you're having some type of communication challenges or documentation challenges, this can kind of bring those issues to a head where you have to deal with them more head on. If it's something you've been putting off or is difficult, this isn't going to make it easier. There's going to be a lot more of this communication is going to be pushed forward so that you know the traffic in your environment, and if you have protocols or procedures or communication lines aren't open between the security engineers, the network engineers, and your development group, this isn't going to make it easier. So it's kind of taking a step back. I'll talk about zero trust processes that create traffic. So this is something where I think we're headed to, and where microsegmentation is one part of this, but it's part of a bigger picture. So kind of looking back, kind of traditional firewall layout, you've got your physical firewalls securing your different zones. What are some weaknesses of it? Well, from pen testers, I hear a lot about lateral movement. Nice big zones, able to move around real easily. Servers are very coarsely grouped together. And it's fairly easy to get out in either 80 or more commonly now, 443. Moving forward with virtual host firewalls, what I'm calling microsegmentation, firewalls in every system. Now operational load goes up because now you need to track, instead of a couple firewalls, now you've got thousands that you've got to track and got to keep up to date with. So making sure you don't block production traffic, you don't impact operations. The complexity of your rules drastically goes up. And then your exfiltration, this is a tough one to judge. So You can still usually get out on 443 on quite a few systems, maybe a little less than before. But now your exfiltration gets harder. You may push your threat actor, who happens to be in your environment, and is able to get into a VM. Maybe that's running legacy code, and he's trying to move laterally. He might have to get a little more creative. 443 isn't going to work anymore. Now he's going to have to use whatever's allowed and poke around. Now, as he pokes around, you know, assuming you've got some alarming in place, you've got thresholds in place. So as he pokes around, if he's going to be very noisy, he's going to start doing a bunch of port scans. You're going to see that traffic, and it's going to be dropped, and it's going to be alarmed from, and hopefully that's going to alert your SOC, who's then going to investigate and kind of give out a big warning bell, something in your infrastructure isn't normal. So this kind of brings you like, well, that sounds like a lot of work. That's pretty tough. What's next? Well, going on with the theme of zero trust and trusting what's happened, why don't we tie in the traffic that's happening? Let's tie that closer into the traffic to where it's being initiated from. So you can say it's initiated from a certain process on a system. So, and I'm going to get a little bit more into this definition, but now you start getting into, with nano-segmentation, tying that together with the application run state. Probably the easiest way to do that right now is through application whitelisting. Is a very common application with it. There's also some runtime verification you can run if your application is advanced enough to where it's actually verifying its running state while it runs, and that ties into what's allowed. It can also reduce some of your operational load a little bit if you trust it enough to create some dynamic rules. But the operational complexity now, so now you've got all these individual micro-segmented firewalls across everything that's running, and now on top of that you're going to add, okay, application whitelisting. Well, it just got twice as hard. So VMware came with a solution on their stack with NSX, and it's what they call app defense. The idea being that basically you study what's running normally, and this is no different from any other vendor, such as Carbon Black, really monitoring what's calling what is the application of open, what is spawning what process, things like that. Getting a baseline, putting that in, and then turning that into automation to where if something doesn't run as expected, you go ahead and alarm on it, or you take some type of action. So what actions can you take? Well, out of the box, you're going to get some functionality. The main one that I see a lot of examples, and it's a little tougher than I'd probably do it first, is complete isolation. So let's say you have a VM, it's seeing some strange execution. It might be from maybe a software update or a software module got updated, and all of a sudden it's not running its normal baseline. So it goes ahead, catches that, and cuts that VM off from the rest of the infrastructure immediately. There are other ways to do this, or that maybe you don't cut it off, you just alert on it, alert to your SOC for further investigation, to take a look and see exactly, is this a known issue? Do you want to stop communication? That's probably a little bit more better way to help baseline that type of change. But here's an example with using security tags and using app defense, how that works. Basically, it sees something outside the baseline, go ahead and quarantine it, and do whatever actions you have automated from there to go forward. In this case, it's block out communications. Another one I'd recommend is also taking a snapshot of the VM for forensics. Immediately when this is detected, might help you if it turns out to be a real incident to get a little more information. So unfortunately, even going that far, so we've got full micro-segmentation in place, we've got firewalls and everything. Now we've got application whitelisting in place. So that should be perfect. Nothing should be able to run. Well, fortunately, that's still a battle. Mainly because, so here's an example that I have here from Spectre Ops. So what they found is if you design your execution properly, in this case they're using a process surface check script method. If you execute through something that's already signed, and by signing a binary, having a digital signature on it, usually if it's especially something included by default in Windows, you're going to allow it. That's pretty normal process. Now if you just, and this kind of branches off the earlier talk of living off the land, which is becoming much more common. By doing that now, you can get unsigned execution by just manipulating the built-in binaries that are on your system. So this happens to be a Windows example. There's plenty of other examples out there, but even this far, there's some holes in here and still some evolution that needs to go on to make this completely effective, so that not only the execution is trusted and the network traffic is trusted, have them all work together, top to bottom. So and it's a very tough thing to do, just due to the complexity of what you're running on. Now, let's say if this was a container, this wouldn't be, even a Windows container, this would be a lot more difficult. So I didn't want to just bring out kind of problems and complexity and issues and how tough it was. I wanted to say how I dealt with this. How did we handle this type of change in our infrastructure to secure our customers but not burn the house down every time we implement a new process. So with physical firewalls, to combat lateral movement, a lot of this comes in feeding your SIM. I put up there Sysmon, very popular tool for Windows logging. Get those course logs. There's some debate whether you should log everything or log certain events, but those tools will allow you to log what you need to catch the type of lateral movement, to catch those Windows events that are going to touch off your SIM. Also on kind of data exfiltration, that one's a little tougher to catch. Looking at your traffic that's coming out of your network. So the top talkers is one way to look at it. I'm a big fan of what's called the Dr. Cole Challenge. And that's 3 lists, it can be daily, weekly, monthly, of traffic exiting your environment. And it's something I highly recommend to spot data exfiltration that either wasn't intended or is part of some business process. And that's it. That first, you want to look at a top 30 list of your source IPs within your network going outside to the public internet that have the most sessions initiated. Looking for your top 30 internal IPs, again going externally, that have the most data. And then your top 30 IPs internally going externally that then have the longest time. So the 3 lists again have the most sessions initiated, have the most data that's exited your environment, and have the longest session times. So moving on to micro-segmentation, as far as the complexity of dealing with all that, I'm a big fan of having some type of standardization in your environment, having some documentation of what is normal, of what should be talking to what is usually a good place to start, and tough for a lot of organizations. With automation, can start out a little lighter with microseg, can use what's built in to help you, and that'll get you pretty far. As far as data exfiltration, that doesn't change at all. You're still doing network behavior abnormality monitoring and detection, and looking every day to see what traffic is going out and is that normal. Last, going on to Nano-Seg, so that gets a lot tougher. And there I start pushing for a different set of solutions. So something that's fairly new in the security industry is SOAR automation. 2 major vendors are Demisto and Phantom. To automate your incident response, your investigations as much as possible, as to where you can keep your analysts focused on parts where they need to make decisions, where they need to think, evaluate the situation. Having is, I think, really to manage it together, manage all your firewall rules, manage all your application whitelisting without bringing the business down or slowing down your deployments or slowing down your developers. That's probably going to be your best bet in order to keep up with them and try to get ahead of what's going on. So that's a summary of my talk on micro and nano segmentation. Hope you learned a little bit. Happy to answer any questions. I guess I wanted to end early here so you had some time for the last session.